at similar figures, kind of an introduction to similar figures, kind of an interesting concept, and we're hoping to understand similarity, scale factor, and basically how to use them in order to determine measurements in figures. If we wanted an informal definition, I'm going to write this as informal. An informal definition of similar figures is basically they have the same shape, there's just going to be a different size. So if you can imagine two triangles, we'll say this one right here, we'll say this is a 30-degree angle, this is a 60-degree angle, this is a 90-degree angle. Then we have a really small one, also the same angle measurements, 30, 60, 90. Maybe the idea here is this is a 10, this is 8, and this is 6. We might say this is 5, 4, and 3. All the angle measures are still going to be the same. All the angle measures on the inside are still going to be the same. The idea is that we've just taken this and we've shrunk it by a factor of 2. The 10 becomes a 5, the 8 becomes a 4, the 6 becomes a 3. These are now similar figures, and we could name them using a similarity statement. When we talk about similar polygons, the key concept here is the corresponding, and this is definitely worth writing down, the corresponding angles are congruent. Okay? The corresponding angles are congruent. Notice each of these are 30, 60, 90, 30, 60, 90. That has to be true, as well as the corresponding sides. The corresponding sides are not congruent, but they're proportional. And what that means is that the same ratio exists. This is 10 to 5, which is basically a 2 to 1. We have 8 to 4, which is 2 to 1. And we have 6 to 3, which is also 2 to 1. That relationship, that proportionality, is basically the scale factor. It is the ratio between the corresponding, if I spell this correctly, corresponding side lengths of similar figures. So the idea here is that when I took this, I said this is going to be 10 divided by 5. That's going to be equal to 8 divided by 4. That's going to be equal to 6 divided by 3, which equals 2 over 1. This is the scale factor. The 2 over 1, it's that common ratio fully simplified between the corresponding side lengths. Notice in this case I always had the big triangle over the small triangle. I always had the first one over the second one. I didn't all of a sudden say big to small, big to small, small to big. Okay, it was always big on top, small on the bottom. Okay. A specific example we can talk about with similarity is we can talk about a dilation. Dilation is either when you shrink or you stretch an object, and if one polygon is a dilated image of another polygon, then the two polygons, they are similar. Let's do an example just to kind of show us what I mean by this. So step 1, graph pentagon ABCDE. And we could do that really quickly on our graph over here. It says secondly, shrink the figure by a scale factor of 1/2. That means my new A, my new B, my new C, my new D, my new E will all be shrunk by 1/2. If these are all X and Y, these are all going to be 1/2 of X, 1/2 of Y. I'll just take each of the coordinates and divide it by 2. In other words, if this is -4, it becomes -2. +4 becomes +2. It's just half of what it used to be. So it become -1 and 3, just taking based off this 2. This was 4, 4. Half of that would be 2, 2. 6 and -2 becomes, let's see, this would be +3 and -1. And 0, 6, half of 0 is still 0. -6 becomes -3. When I shrink these, and I draw this is just going to be a smaller rendition of the original shape. So we could graph this, and when we just make these are going to have the exact same angles. The corresponding angles are going to be congruent. When I check this, the corresponding angles will be congruent, and the corresponding sides, they will be proportional. So check mark there, check mark there. What that means is yes, these two, after they've gone through the dilation, are similar figures. Okay, what we have here is we have a similarity statement. It says think, or THINK, is similar to LARGE. What that means is that what we can do is we can set up something called a statement of proportionality. What that means is that I have basically the idea that TH, the first two letters here, are going to be similar to the first two letters there, LA. The second two letters, HI, will be similar to AR. The third two letters, IN, match up with these third two letters on this side. The fourth two letters, NK, would be over GE. And then I basically take the first and last, TK, and I put that over the first and last, LE. This sets up a statement of proportionality. Now I pick any of those two that are going to have both the top and the bottom. So what I might do is I might pick TK, the last one, and LE. Notice that TK right here is a length of 4. LE has a length of 8. That would give me a scale factor when I fully simplify it of 1 to 2. Okay. What I can do then is with this 1 to 2, if I know it's always the smaller to the bigger, this is the small over big in this case, with 1 to 2 I can basically say, well, if this is 12, that's going to become 6. From 1 to 2, if this is 2, this becomes 4. If this is, I don't even know what that says, if that's 5, I have no idea, if this will be 10. If this is 3, this will become 6. The idea here is I can set up a ratio or a proportion in order to solve for this. Same thing goes on with other problems, but this is basically using this statement of proportionality to find the scale factor. Then using the scale factor, for instance, if I know this is, say, x over 12, I could use a proportion to say that 12 equals 2x. Well, that x equals 6 in order to find this length up top. Another idea here, we can say, are these polygons similar? What I need to check is I need to check two things. Are the corresponding angles congruent? Okay. Well, I have this angle congruent to this angle congruent to this angle here congruent to this angle, and by process of elimination, these two angles also have to be congruent. So yes, the corresponding angles are congruent. Now what I want to do is I want to check to see if the corresponding sides are proportional. So I'll say 150 divided by 165, and I'm going to ask, is that equal to 180 over 192? These are just the corresponding sides, just to see if they have the same ratio. Say, is that equal to now 140 over 154, and is that equal to 120 over 128? All of these need to simplify to the same fraction. Let's see what happens. If we simplify this, we'd have 10 over 11. This would become 15 over 16. This becomes 10 over 11, and this becomes 15 over 16. Because these are not all equal to each other, we have to say no. Okay? Though the corresponding angles are congruent, the sides are not proportional. The corresponding sides are not proportional. So that's what causes this to not be, these two figures to not be similar. Similar concept here. What we would do is we'd pick the two sides, corresponding sides that are sharing the same concept. So we might say that SP over HN is going to equal 88 over 66, or that would give us a ratio of 4/3. This is our scale factor again. Our scale factor. If I can spell anything, scale factor. Then what I could do is I could say something like, hey, 28 over x, so like this part, 28 over, say, x right here, has to be equal to, 4/3. I could cross multiply, that'd be 4x equals, 28 times 3, which is 84. And that would give us, 21 is how long this side is over here. In a similar fashion, I could solve for all these different sides. I would just continue with the same process. So this last question, are these polygons similar? We check first the corresponding angles. This angle with this angle, this angle with this angle, this angle with that angle, this angle over there with that one, and the corresponding angles are congruent. Next, I'll check the corresponding sides. I'll say 27 over 18. Ask, is that equal to 30 over 20? Is that equal to 21 over 14? Is that equal to 78 over 52? Is that equal to 39 over 26? These are all question marks. I have to simplify my fractions to see if they are. This becomes 3/2. This is 3/2. This is 3/2. That one's 3/2. And finally, the last one, also 3/2. So what I can say is, yes, these two polygons are similar. And I'll say both the corresponding angles are congruent and the corresponding sides are proportional. So the two polygons are similar. This is the idea that the corresponding angles must be congruent and the corresponding sides must be proportional in order to have similar polygons.